your FortiGate, specific roles for specific interfaces. Use administrative protocols carefully. Don't just let anyone ping from that interface if it is not needed. Use DHCP server and use DHCP server scopes so you can create different DHCP options for that local area network. You can block specific MAC addresses from receiving IP addresses and use device detection and active scanning. You want to know which devices initiate traffic on that interface. Now the next thing to do is to create or configure a static route that will lead to your ISP. Now it is usually created using the default route, which actually means that any packet that is destined to anywhere and it does not have any entry in the routing table should head up towards the specific gateway, which is usually the WAN gateway. The next thing to do is policy and objects. That is the bread and butter of your FortiGate firewall. It is where you create rules that match any traffic that comes in or gets out of your FortiGate. Assuming that it matches the traffic, you have two decisions. The first one is to accept, the second one is to deny. Now you can create different policies according to different topologies. The basic policy is the full access policy, which allows local area network to get out to the internet through the WAN interface. So incoming interface can be just about any LAN in your network. The outgoing is the WAN interface. Source can be different users' devices, but let's assume that we deal with just about anyone. Destination also can be specific destination, but let's assume that any destination is allowed. You can set up different scheduling and services. Now, again, you can deny specific protocols, but for our case, we will allow any service. Now, the learn policy is another topic that I have made a video specifically on that, but that's not the issue right now. Now, whenever FortiGate matches the traffic, the next decisions are we going to log the traffic? Are we going to NAT the traffic? NAT is also very, I would say, not difficult, but it is a tough topic to understand. And then it implies the security profiles, which can be antivirus, web filtering, IPS, and so on. And our last setup is actually moving into the log and report and see whatever happens in your FortiGate. Now, there's a lot of happening whenever traffic comes in and gets out, whenever an admin logs in into one of the interfaces, whenever there's a VPN tunnel that initiates or stops working. You need to maximize your understanding on what is happening on your network, and the best thing to do is to look at the login report and understand your network baseline. For years, it is known mostly as the #1 web application vulnerability, SQL injection, when a user input becomes an attack vector. Don't go anywhere. To get more easy setup tips for your FortiGate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. To understand SQL injection attack, we have to go back to the basic. So we have a web app, it runs on our browser, and just about any web app has different input fields that we enter user credentials, or we enter reviews, or just about anything, comments, and so on. Whenever we do it, our web server that hosts the web app contacts its database. It does so using a very specific language which is called SQL. SQL is actually a structured query language, a special language that allows us as users and allows our web server to update, to delete, or to request information from the database. To do so, our web app sends SQL statements to the server. Now you can send a batch of SQL statements. There is a group of 2 or more SQL statements that are separated by semicolon. The server processes our request and returns back the results. Up until now, fantastic. It works just fine. Now, where is the vulnerability? When our web app just doesn't sanitize. It doesn't sanitize our user input. It doesn't differentiate between plain text that is used as the user input and an SQL statement that is entered in the input field and sent to the database. Let's look more closely. When we have a user input, the application code looks something similar to that. When we enter our name, that is our username, it is being added to the code itself. Now imagine what will happen if I enter the following code instead of my name. It is actually an SQL statement that was entered in our input field. So now our application code looks like that. Offer, which is my username, or 1 equals 1. Now the database pulls down the records for every user, wherever 1 equals 1. Remember, 1 equals 1 is always true. The SQL is actually a valid SQL statement and it will return all rows from the user's table since or 1 equals 1 is always true. So our pure plain SQL statement is being treated as any other text input. It is being injected directly into our database, and from there the opportunity for a malicious attacker is huge. Welcome to our Fortigate top 5 tips, and this time we are dealing with the ping command. Tip number 1. When we use the ping command, we use the execute command. So we'll use the execute ping and we'll choose our destination as 8888, which is Google's DNS server. Now we can see that our ping size is 56 bytes and Fortigate sends 5 packets at a time. Now we can change the size of our ping. How do we do it? We use the execute ping options. Let's view the settings. All right. And now if we will use the execute ping options, data size, we can choose ICMP packets to be in different size. Let's choose 90. So now our ping size is 90 bytes. Let's choose the same target. Execute ping towards 8888. And you can see that our ping size is 90 bytes. And to our second tip. Now, if you do networking for a long time, you probably send continuous ping packets towards different destination, different interface. So you have to change the amount of packets to be continuous or to be at a different size than the 5 packets that are sent by default. How do we do it? We use the execute ping options and we use a different repeat count. Currently the repeat count is 5. Now let's change it to 15. And now let's ping again and let's ping the Google DNS server and let's see how many packets are being sent. And we can see that we have 15 packets that are sent. And now for our third tip, let's clear that out. Now we have different interfaces in our Fortigate and sometimes we wish to send ping packets from different interfaces. So how do we do it? I have currently an interface at the 10.0.4.1. So let's use the same execute ping options. And now let's choose a different source. In my case, it's the 10.0.4.1. And now if I'll use the same ping command, the packets will be sent from the 10.0.4.1. Moving on to tip number 4. Usually a ping command is being discarded after 64 hops. Now we can choose a different integer. We can choose an integer between 1 and 255 hops. How do we do it? We use the same, sorry for that, we use the same execute ping options, time to live, and let's choose 220 hops, 220 hops, and now our ping packet will be discarded only after 220 hops. Alright, and now let's move over to our fifth tip. Sometimes as an administrator, you use different settings. Let's change the settings of our ping command. Let's use a repeat count of 8. Let's use a different data size. Let's make our ping size 80 bytes. And let's use a different source. Alright, let's use the 10.0.4.1 as our source. Now, if we will use the view settings, we will see that our repeat count is 8, our data size is 80, and our source address is the 10.0.4.1. Now, you want to reset those settings. What do? You use the reset command. And now if we'll take a look at the view settings, we will see that it all came back to the default settings, which are 5 packets, 56 bytes, and the source is according to the interface that you work within. Now, if you like our channel, please subscribe. In this video, I'm going to show you the 5 top routing commands for your Fortigate, and we are starting right now. Welcome to our top 5 commands, and this time it's all about routing. Your Fortigate is not only a next generation firewall, it is also an OSI layer 3 device, just like any other professional router. So let's start right now. And the first command, our first command will be the get router info routing table. And now there are 2 variants of that command. You can see the full routing table, including the inactive routes. That's the full routing table, including inactive routes. And you can see only the active routes. And there we use the all with our command. Our next command, which is very useful whenever we wish to see more details on a specific destination, we can use the get router info routing table. Now we'll use the details for our destination, and this one it's going to be the default route. And we can see that when we ask for the default routes, we get 2 static routes. We get one from the WAN to interface, and its IP address is the 10.0.5.2, and the second one, which is actually the active one, is the one from our WAN 1 interface at the 10.0.3.1. We can also see the different administrative distance. The active one has an administrative distance of 10. The inactive one has an administrative distance of 20. There are times when you have 2 static routes to the same destination. Both static routes have the same priority, have the same administrative distance, and you wish to load balance the traffic between them. Fortigate load balances the traffic automatically, but the load balance algorithm can change. So let's change our 2 static routes to be within the same priority and administrative distance. Let's look at both. They are in the routing table, in the active routing table, and yes, they are. And now let's configure system setting. Sorry for that. It always happens. And set v4 ECMP mode. ECMP is equal cost multipath. That says actually that whenever we have 2 static routes using the same priority and administrative distance, Fortigate will load balance the traffic. How will it load the traffic? Well, there are actually 4 different algorithms using the same source IP, using an interface weight, usage, that is whenever on one interface you get into a specific threshold, the traffic moves to another interface, and you can also use the same destination and source IP. And now we move on to our fourth command, which is the link health monitor. Link health monitor is a mechanism that protects your FortiGate from a route failover. Now assume that your FortiGate has two ISP connections, ISP1 and ISP2. The first connection, which is WAN1 connection, is active since it has a lower distance. The second static route is not active. Now whenever FortiGate notices that the route through WAN1 is not working anymore, it transfers, or it makes the second route, the second static route, it makes it active. It makes it active so it can route the traffic to the internet. How do we do it? We use link health monitor. Config system link monitor. Edit, that is the name of the link health monitor. Set the source interface. And now set the server, that is the server that we will probe. It can be 8888, which is Google's DNS server, or any other stable server. Set the gateway IP. Now set the protocol. It can be using ping, or it can use TCP echo or UDP echo. And then set the update static route to enable. Moving on to our last command, which is the diagnose firewall Peerout List. Now, this command actually shows us the policy-based routes table. Now, you can create a policy-based route, which is a much granular way to create routes using the policy routes under the network menu. Use it carefully, and use it only when you have a very specific needs from your route entry. Hey everyone. So you have your Fortigate and its switchboard includes physical ports. Each can be configured with its own IP address or be associated to a virtual switch, either a soft switch or a hardware switch. That is, we are actually creating switches within the physical switchboard. But what is the difference between a soft switch and a hardware switch? Well, the difference is that in soft switch, the implementation itself is done at the software level and not on the hardware level. That is similar to saying, okay, port 1, port 2, port 3, you all belong to a soft switch that we will name it marketing, and it will have an IP address of 10.0.0 and so on. In a virtual hardware switch, the implementation is done over the physical ports themselves, where each port, each interface is configured in its hardware level to be a part of the same hardware switch. That is a much superior way to handle traffic, and in terms of performance, it makes a huge difference. Now, whenever traffic enters the switch and it is destined to one of the interfaces that belong to that switch, decisions are made by the physical switch itself, its forwarding table, which is actually the MAC table. Alright, so let's configure a hardware virtual switch. Alright, so let's move over to our command line, config system virtual switch. And now if I'll type the get command, I will see that currently I don't have any virtual switch already configured. So let's name one. Let's call our virtual switch, let's call it marketing. And let's set it up from the physical switchboard. All right, and now let's configure the different ports that will make out this switch. So let's use internal 4 and let's use internal 5 also, and let's use internal 6. All right, let's get back to our, all right, so now let's use the same command as before, config system switch, config system virtual switch, and let's see if we have a switch that is configured. Yes, we have. Here's our marketing switch. All right, now let's refresh our interface pane to see our new virtual switch. And there it is. Now, if we will head over to our setting page of that switch, we can configure its IP address, its management. Let's use LAN2 as our alias, and let's get him an IP address, and that's right. I'm using the same. Let's allow anyone to connect to it using HTTP and HTTPS, and let's allow ping also. And every device, every appliance that will connect to that subnet will get an IP from its DHCP server. And let's also add up device detection. Okay. And there we have it. We have a hardware virtual switch with its own subnet, with its own DHCP server. Any appliance that will connect to it will get an IP address from its pool, and any traffic that will head up to one of the interfaces that is within the marketing switch will be forwarded using the forwarding